All right, so this section 3.1, all we're doing is we're learning a new function. We've been talking about linear functions pretty much all year long. Those are the mx plus b types. We know that they pass the vertical line test. We know that their inverses also pass the vertical line test, so their inverses are functions. But today we're learning a new parent function, if you will, a new parent function, and that function is called the absolute value function. Okay? Now, first of all, an absolute value is written like this. You might have seen it. These are no longer like brackets or parentheses. You can't just arbitrarily use these. These are just vertical lines that are tall enough so they don't look like ones or L's, right? They're kind of like grouping symbols, but they mean something very specific. Now, what you know about absolute value from your previous Algebra 1 class is anything that comes out of there must be what? Positive. Anything, I'm going to write that. Anything that comes out of there, this is very, very formal writing, right? Anything that comes out of there must be positive. Kind of like our attitudes at the end of the pep rally, right? When you come out of the pep rally, you better be positive. You better be positive going in because y'all have to supply the energy. Anything that comes out of there must be positive. Okay, so what does the absolute function mean? Why do we even have that? Well, the absolute function basically just represents the distance between x and 0 on the number line. That's it. It measures the distance, and distance in this case is not directed distance. It's just the distance, right? You don't measure something and say, oh, it's negative 5 feet. You just say, oh, it's 5 feet this way or it's 5 feet that way. That's what the absolute value does. It measures the distance between x, some number x, and 0 on the number line. So for instance, what would be the absolute value of negative 5? 5, because how far is negative 5 from 0? 5 units. What would be the absolute value of positive 5? 5, because how far is 5 from the origin? 5, okay? So positive and negative numbers have the exact same output. Positive and negative numbers have the exact same output. What about 0? How far is 0 from itself? If you had to quantify, you'd say 0, right? 0 is itself, so the absolute value of 0 is 0. But aside from that, every other input, negative 3, positive 3, negative 4, positive 4, they have the exact same output. And if I were to create a function then, f of x equals the absolute value of x, or I was to graph what this looks like in two-dimensional Cartesian plane, it would look like this, okay? This is what the graph looks like. The x-axis measures your input, and the y-axis measures the distance from 0, right? So as we already said, if you come over here to 5, when x is 5, what's the absolute value of 5? It's 5, right? What if I come over here to negative 5? What's the absolute value of negative 5? 5. Okay, so do you see a symmetry taking place here? There is a symmetry. Okay, if you let the y-axis be its starting symmetrical axis, we could say this graph is symmetric across the y-axis. Okay, if you folded this along the y-axis, it would perfectly coincide with itself. It has y-axis symmetry. Later on, we're going to call that an even function. But right now, just know that the y-axis is the axis of symmetry. And we could talk about the vertex if you want to. We could call this the vertex, much like we do a parabola. It's going to be at 0, 0. This is a very important point because when we do transformations of this, and oh yeah, we will, we're gonna stretch it, we're gonna compress it, we're going to reflect it, we're gonna move it left, right, we're gonna move it up or down. This vertex right here, if you could figure out where the vertex goes under the transformations, then all you got to do from that point, once you know where it is draw it going up like a V for victory, or down like a V for downward victory, I guess. Yeah. I call this the V for victory graph, right? Like after our win over Canyon tonight, we're gonna be like, oh, we got a V tonight, right? People, hey, how'd you feel? Yeah, we got a V tonight. They don't say V though, do they? They say we got a W. It's more fun to say W. Did you know in Spanish it's not a W, it's a double V, right? Yeah. So we got a double V tonight, right? Double victory. Yeah. The other characteristic of the graph, the line of symmetry, so the symmetry x equals 0. The y a vertical line is also the that's where it starts. Very important point. This is the origin. All right, what do you think? All x, x is the element of the numbers. So people did this on the test. Negative infinity is less than x is less than infinity. Okay. If you do that, you get one out of it. Is there anything else that we can say about this graph? A, B, C, D. Right? Arbitrary. Right? Yeah. So it does the exact same thing. The note's just called little a. Letters on X minus H. Letters we call that previous session. C. Standard transformation form. Again with x squared. The C and the D. All the G's. 1, G sub 2, G sub 3, G sub 4, G sub 5. Sub means right? G sub 1, G sub 2. They belong to G after the minutes. Plus 6 is added outside the function. Is it 6 or down to 6? Six, the vertex is 0, 6. Right, what's the new coordinate of the vertex? Negative 4, what's the y coordinate? No, it's the 0. It's left. Okay, so what's that? Well, come out here to negative 4, put the vertex, and we didn't change the slope. So it's negative 1 left, positive to the right. G sub 3. So say x-axis reflection. Now it's positive to the left and negative to the right. It's a BS so it's a little bit wider. Taller, thinner, steeper, whatever you want to call it. It's just a little bit steeper. Yeah, the smoke is